Hello, ladies and gentlemen of Algebra 2B. This is Unit 8, Video 5, talking about properties of radicals. So you need to be able to simplify radical expressions using properties of radicals. So radicals are kind of a big topic of what we've been talking about. So let's kind of get into it here. All right, so a couple of big ideas to remember for radicals. And the bigger idea is this, is that if I have anytime I've got a product of two things underneath the square root, I can separate it. So if I've got like the square root of 12, I can write that as the square root of 4 times the square root of 3, so that I can break that apart and call that the square root of 4. I can take that square root of 4 times the square root of 3. So I can break that apart. Second piece is this, is that if I've got an entire division problem under the square root, I can break it apart and take the square root of the top and the square root of the bottom, to where if I've got the square root of 5 over 9, I can take that as the square root of 5 over the square root of 9. Now, these are a couple big rules that you want to remember because they're going to come in handy when it comes to simplifying and solving. So, a couple things. Simplifying a radical. No radicals in the bottom of a denominator, in the fraction, no radicals in the denominator, and no fractions underneath a radical. Okay, kind of the reason for that is that a lot of radicals are continuous. So here it's actually like you're trying to divide by something that never ends, because sometimes the square root never ends. And no fractions underneath the radical, because you can always try and simplify that. And if you have a fraction underneath the radical, then you will have a radical in the bottom, and that's not okay. So rationalizing the denominator, I say this quite a bit when kids get into this unit. Rationalizing is going to be multiplying by 1. So if I take the square root of 9/5 here, what I want to do first off is I want to separate it to square root of 9 over square root of 5. And then I'm going to multiply both the top and bottom by the bottom. So I'm going to multiply by square root of 5 over square root of 5. All right, so technically this is 1. Okay, same thing on top, same thing on bottom. But here's what happens. On the top, I get square root of 9 times square root of 5. On the bottom, square root of 5 times square root of 5 is going to be just 5. So on the top, you have square root of 45 over 5. So then you can simplify that to 3 square root of 5 over 5. So there's my answer. So here, cube root of 9. So I'm looking at the cube root of 2 over the cube root of 9. So I want to multiply both the top and bottom. And here's what I'm actually going to do. I'm actually going to have to be a little clever here and realize that 9 is 3 squared. Okay? So what I'm actually going to want to do is multiply by the third root of 3. Okay, and here's what I mean. Here's why I'm doing that. All right, 9 is nothing more than 3 squared, so that's going to be cube root of 27, which is just going to be 3. Then up top, I'm going to multiply that together underneath, and I'm going to get, that's going to be 2 times 3. The cube root of 6, then on the bottom, I'm going to get 3. There's my answer. So I'm trying to get rid of whatever this root is. So here is 3 squared, so I multiply by one more 3. This becomes 3 cubed, so there's my answer. So simplifying 198, so I need to start thinking about your perfect squares, so like 1, 4, 9, 16, 25, 36, 49, all those. Start thinking about what can I break that apart using. What can I break that apart using one of these? So 198, if I break it apart by 2 or by 3 or by 4 or by 9, let's see what I can do. I know 9's going to work, and that's going to be 21. So 9's a perfect square, so I can take a square root there. So that's going to be 3 square root 21. There's my answer. All right, I can't split apart, That splits apart to 3 and 7, but neither one of those help me, so my simplified answer is going to be 3 square root of 21. 3 square root of 54. So 54, I will break apart into 9 and 6. So I have this 3, then I have another 3 from the square root of 9 times the square root of 6. There's my answer. Now for this one, when I look at ones with variables involved, I like to break it apart. So I'll deal with 128, I'll deal with x to the 4th, and I'll deal with y to the 3rd. I'll deal with them separately, and then I'll put together what's on the outside, and I'll put together what's underneath. So 128, just if I play around with that a little bit, I know 4 works, so 4 and 32. I know 32 can go 4 and 8. You know what? I'm just going to go simpler here and say 128 is going to be 16 and 8, so I can go 4 again. So 128 divided by 64. So I know that's going to be 64 and 2. And I did that with about literally 3 minutes. Square root, so that's going to be 8 square root of 2. So, square root of x squared, square root of x squared, split that apart. So that's just going to be x times x, better known as x squared. So y squared, square root of y. So that's going to be y. So if I put together what's on the outside, I get 8x squared y. Then underneath, I'm going to put 2y. So final answer here is going to be 8x squared y square root of 2y. There's my final answer. So that's going to be how I simplify that. Now here, a couple different things I can do. What might be a little bit easier is to do something like this. Kind of put it all under one thing. So it looks like this. So 24 times 12 is going to be 288. X to the 7th, y to the 4th. That's a 7. So 288 can be broken apart. Oh, let me back up. Let's break this apart now. It's 288, x to the 7th, y to the 4th. So break this apart into 144 and 2. X is 7th. This would actually become x squared, x squared, x squared, and x. So square root those. So I'll be left with x times x times x times square root of x. Y to the 4th would be y squared times y squared. So that's going to be y times y on the outside. So square root of 144 is 12. So I'm going to go 12 square root of 2. So when I put all this back together, 12 x to the 3rd y squared square root of 2x. So I put these together with the 12 on the outside, and I put together 2 and square root of x underneath. So here, once again, remember, you cannot have a fraction in a square root, and you cannot have a square root in the denominator. So 18x to the 4th over 7y squared. Now, if I break apart the bottom, so that's square root of 7 times y. So my simplified on the bottom would be y square root of 7. All right, so now to rationalize that denominator, I don't need to multiply by the y. I multiply by your square root of 7. So now I get square root of 7 times 18x to the 4th. So that gives me 126x to the 4th all over y. So now 126, I try to break it apart. I can split that into 9 and 14. And x to the fourth should just be x squared. If I break it apart, it's x squared, square root both of those, it'll just be x and x, so x squared. So 3x squared, square root of 14. So that's my numerator. So my whole thing here is going to be 3x squared, square root of 14 over y. There's my answer. So a lot of pieces to this. So I like to break it up and then put it back together once I've done that. So 6, this one actually might be a little bit easier. So if I break it apart, go 5 and 4a, I can break apart my denominator into square root of 4 times square root of a. Square root of 4 is just 2. So this is like saying square root of 5 over 2 square root of a. So then to rationalize it, I can't leave a square root in the denominator. I'm going to multiply by 1. I call it 1 because it's the same thing on top and bottom. So what I want to do instead is this. I'm going to get square root of 5a, okay, when I multiply these two. Then on the bottom, I'm going to have 2, and then when I multiply these two together, it's going to be just a regular a. Now, I can't simplify it, okay? This is my answer. So square root of 5a over 2a. Do not try and cancel out the a's. Because 1 is underneath the square root, 1 is not, you cannot cancel those out. So if I look here, m to the 9th over n to the 7th, and it's a square root. So if I take just the top over the square root of the bottom, well, the bottom becomes, well, let's do this. Start with the bottom. So that'll be n squared times n squared times n squared times n. So it's the square root of all those. Well, the square root of n squared is n times square root of n. So simplified, this becomes n to the 3rd square root of n. On top, what happens is this. This becomes m squared times m squared times m squared times m squared times square root of m. Square root of all these. So that becomes m to the 4th square root of m over n to the 3rd square root of n. So now all I'm rationalizing is this, the square root of n. So now on top I get m to the 4th square root of mn. On the bottom I've got n to the 3rd times another n, so that becomes n to the 4th. There's my final answer. So here, 4th root. That's what I'm looking at, 4th root here. So if I go 4th root of 3x over a 4th root of 2. So now here's where I've got the 4th root. So ideally I would want 2 to the 4th. So if I've got 2, that means I'm going to multiply by 2 to the 3rd. Times the top and bottom. Sorry, not 3. What am I writing? 2 to the 3rd power. So that gives me the 4th root of 2 to the 4th on the bottom. Then on top, it's going to give me the 4th root, and I'm going to multiply it. 2 to the 3rd is nothing more than 8, so that's going to be 24x on top. So on the top, I'll have 4th root of 24x. On bottom, I'll have just 2. So on the top, I can break that apart, but there's no perfect, I can't break that apart into anything that's going to work because because that'll be about as far as I can get, so that'll be my answer. All right, so here, this one is going to get weird, okay, because here's kind of what I'm going to do. I'm going to keep that 5 out front. I'm going to break this apart to the 4th root of 24, 4th root of x to the 3rd. Over here I've got 4, 4th root of 54, and 4th root of x. So I'm going to move outside. So 5 times 4 is outside. I'm going to keep it outside. Then 54 and 24 I'm going to put together underneath. So 54 times 24 is going to be 1296. Then I'm also going to have the 4th root of x to the 4th. Now the upside is that this 4th root and x to the 4th, that just tells me that's going to be x. 5 times 4, that's going to be 20. 4th root of 1296, that is where things are going to get fun. If I play around with that, this is actually 6 to the 4th power. So again, those cancel out. So after all that noise, my final answer is just 120x. So after all that, it wasn't too complicated. Again, all I did, I kind of let my calculator do the legwork. So since I know it's the 4th root, I raised it to the 1 divided by 4 power, and it actually gave me 6. And I just tested it to see if it would work. I had no idea if it would or not. So here, if you're looking at, again, same kind of similar idea here. So I'm going to keep the 7 out front. Sorry, that's not very easy to see, is it? 7 out front, 3rd root of 75, 3rd root of a to the 4th, 3, 3rd root of 45, and 3rd root of a squared. So again, I'm breaking it apart into pieces. So I'm going to put 7 times 3 together. Underneath, I will put 75 times 45. So that's 3375. And I'm going to have the 3rd root. I'm going to put the a's together. That'll be a to the 6th. So then those two, that's going to be, I divide them. So that's going to be a squared. 7 times 3 is 21. And the 3rd root of 375 is actually 15. So that's going to be 315a squared. All right, play around with this. There's a lot of pieces. Take your time and take it piece by piece and start to understand the relationship between the roots and the powers.